Hi, welcome to this Core Maths video. In this video, we're going to look at the GCSE Further Maths topic of integration, and we're going to look at the definite integral. Now, we've looked previously at indefinite integration, so whenever we've integrated something such as 2x with respect to x. So if we were integrating 2x with respect to x, we would get, well, we would increase the power of x by 1. So at the minute it is 1, so when you increase by 1, you'll then get x squared. And then we'll divide the coefficient by that new power. So 2 divided by 2 is equal to 1. So we're not going to write 1x squared, we'll just write x squared. But then we had that plus c on the end. And that plus c, we didn't know what it was, that constant of integration. Because remember that if you were to take something such as x squared plus 20 and you differentiate it, you get 2x. If you have x squared minus 4 and you differentiate it, you get 2x. We didn't actually know if there was a number there on the end there or not. So that's why it's called indefinite integration, because it has the plus c. Now in today's video, we're going to look at definite integration. So that's where we find the definite integral. So if we had something like this, where we've got the integral of 2x with respect to x between 5 and 1, we have these two limits. The upper limit here is 5 and the lower limit is 1. And this is particularly useful for our next topic that we're going to look at after this video, which is finding the area under a curve. And you use this a lot whenever you're finding the area under a curve, this definite integration. Now it's called the definite integral because whenever we integrate this, we're going to put in our limits, and whenever we evaluate it and work it out, what we find is the plus c's cancel out. So then there are no plus c's, so we have a definite answer. There's a certain value, so we don't have those plus c's. So that's why it's called the definite integral. Okay, so let's have a look and see how we would work this out. So let's have a look at our first question. So our first question, we've been asked to find the integral of 2x with respect to x between 5 and 1. So these are our limits, 5 and 1. And if we wanted to work out something like this, the first step is we need to integrate. We need to integrate our 2x with respect to x. Now, one thing I want to mention is that whenever you're doing these definite integral questions, that you use the right notation. So if we had the integral of 2x with respect to x between 5 and 1, our first step is then we integrate it. And then we're going to integrate this. We're going to integrate the 2x. So we're going to put some square brackets down, okay? And we're going to integrate 2x. So to integrate 2x, we'd increase the power by 1. So it would be x squared. And then we would divide by the new power. And whenever we take that coefficient and we divide it by the new power, 2, we get that's equal to 1. So it's 1x squared, but we're just going to write x squared. Now here, I'm not going to bother to write the plus c, and you'll see why in a minute, okay? So I'm just going to write x squared. And then I'm going to close those square brackets. So if you integrate 2x with respect to x, because it's definite integral, we're just going to write x squared. We're not going to write the plus c. You could, in theory, write the plus c, and you'll see later on that they're going to cancel out. But so just to save a bit of ink, we're not going to write the plus c there. And then, because we have our limits, our upper limit is 5 and our lower limit is 1, we're then going to write 5 there and a 1 there. So we put our square brackets, we put what we get when we integrate 2x inside the bracket, forgetting our plus c, and then we've just put what we're integrating between here with the 5 and the 1, the two limits, the 5 and the 1. Okay, so now what we need to do is we need to evaluate this. We need to substitute in our limits. So what we're going to do is we're going to substitute in 5, we're going to substitute in 1, and we're going to take them away to see what we get. So first of all, what we'll do is we'll substitute in the 5, the upper limit to begin with. So we're going to substitute in 5 here. Now I've put then curvy brackets here, and we're going to do 5 squared. So we're going to write 5 squared, and then close brackets. And then we're going to subtract whatever we get whenever we substitute in our lower limit. So you always subtract these. So you're going to substitute in the upper limit, you're going to substitute in the lower limit, and you'll take them away. So let's do then 1 squared, and then close brackets. And this is why we don't need to write our plus c, because if you have the plus c here, whatever value it is, you're then going to take away the plus c, and c take away c is equal to 0. So that's why whenever you're doing definite integral, whenever you integrate, you tend not to write the plus c. Now some textbooks you look at may include the plus c here, and then whenever they do the subtraction, they'll then cancel out. Other textbooks and also the mark schemes for GCSE Further Maths, if you look at the GCSE Further Maths questions and their mark schemes, whenever you look at those, whenever they integrate, they tend to just get rid of the plus c straight away, so they don't actually include the plus c. So that's why in this video I'm not including the plus c here, so that whenever you're looking at the mark schemes, you're saying, well, actually, because it's definite integral, we don't need to include the c. The mark scheme doesn't include the c as well, so that's we sort of match up. Okay, so let's just recap what we've done so far. We've taken the 2x and we've integrated it, and we've got that's equal to x squared. We've put that in square brackets and put our two limits there to the right of it, and then we've substituted in our two limits. Now what we're going to do is we're going to work them out. So we're going to work out what 5 squared is, so that's 25, and we're going to take away what 1 squared is, that's equal to 1. And then we're going to do 25 take away 1, and 25 take away 1 is equal to 24. And that's it. So if you've been asked to find the integral of 2x with respect to x between 5 and 1, the answer would be 24. And that's it. Now there's some fantastic calculators that can work this out for you. So if you've got a calculator, some calculators can work out the definite integral for you. So you can actually press the integral of 2x with respect to x and type in 5 and 1 and press equals, and I'll just tell you the answer of 24. And that's quite useful to be able to check your answer as well. And that's it. So that's how you work out the definite integral. And it's very important you start using that notation, particularly if you're going on to A-level maths, that you are consistent with that notation. So when you integrate, use the square brackets and you put the limits to the right of it. Then you put in your curved brackets and you substitute in the limits and you subtract to work out what it's going to be. Okay, let's look at our next question. Okay, so this time we've been asked to find the integral of 6x squared with respect to x between 1 and 0. Okay, so let's work this out. So we've got the integral of 6x squared with respect to x between 1 and 0. Okay, so our first step is we're going to integrate this. So to integrate it, what we're going to do is let's put our square brackets down. We're going to increase the power by 1. So it was 2, it's now going to be 3 or cubed. Now we're going to divide the coefficient by the new power. And 6 divided by 3 is equal to 2. So we've got 2x cubed. And then close our square brackets and then put our limits to the right there. So 1 and 0. Okay, now we're going to work this out. So we're going to substitute in 1, we're going to substitute in 0, and we'll take them away to see what we get. Remembering here we didn't put our plus c because we don't need to, and I'm just matching it with what the mark schemes do. Okay, so now what we're going to do is we're going to put our curved brackets. We're going to do 2 times 1's cubed. We're going to do 2 times 1 cubed, close brackets, and we're going to subtract what we get when we do 2 times 0 cubed. So just replacing the x with the two values that we need to substitute in. Okay, now it's a calculator paper, so you can just type this into your calculator and work this out. I'm just going to work it out manually here. 1 cubed is equal to 1 times 2 is equal to 2. And then we've got subtract, and 0 cubed is equal to 0 times 2 is 0. So we're left with 2 subtract 0, and 2 subtract 0 is equal to 2. And that's it. So if we were asked to find the definite integral of 6x squared between 1 and 0, the answer would be 2. Okay, let's look at our next question. Okay, so this time we've got find the integral of 3x squared minus 12 with respect to x between 4 and 2. So we've got the integral of 3x squared minus 12 with respect to x, and we're evaluating that between 4 and 2. Okay, now let's have a look at this. So this one's a little bit different than the ones we've looked at so far, because the ones we've looked at so far were just 6x squared and it was just 2x. This time we've got 3x squared minus 12. So it's the same process. We just need to make sure we're integrating all of this. So let's integrate it and see what we get. So let's integrate each term separately. So let's start off with the first one. So put our square brackets down. So when we increase the power of x by 1, we're going to get x cubed. And then we'll divide by the new power. 3 divided by 3 is equal to 1. So we've just got our x cubed there. Now let's integrate our minus 12. So that'll be minus 12x. Remember, whenever you integrate just a number such as 8 or 10, you get 8x or 10x. If you were to integrate minus 12, you get minus 12x. And then remember, it's definite integral here, so we don't need the plus c. If you accidentally put it in and then sort of get rid of it later whenever you do subtraction, that's totally fine as well. But remember, in the mark schemes, they tend not to include it there, so I'm not. Okay, and then we need to put our limits here to the right. So 4 being the upper limit goes up there, and 2 being the lower limit goes down there. Okay, now we just need to evaluate this. We just need to substitute in 4, substitute in 2, and take them away and see what we get. So that's going to be equal to. So we're going to do 4 cubed minus 12 times 4, and then close brackets. And then we're going to also then do 2 cubed minus 12 times 2. So just substitute in 4 for the value of x and substitute in 2 for the value of x. And you can just type this into your calculator if you wanted to. I'm just going to work it out manually. 4 cubed is equal to 64. So we've got 64 minus, and 12 times 4 is equal to 48. Close brackets. And then here we've got 2 cubed. That's equal to 8. And then we've got subtract 12 times 2. And 12 times 2 is 24. So here we've got, if we work this out, 64 take away 48. That's equal to 16. And then we've got minus. And then if we work out this bracket, we get that's equal to minus 16. So we've then got 16 subtract minus 16, and 16 subtract minus 16 will be 16 plus 16, which is equal to 32. And that's it. So if we were asked to integrate 3x squared minus 12 between 4 and 2, the answer would be 32. And that's it. Okay, let's look at our next question. Okay, so let's have a look at our next question. So this time we've been asked to find the definite integral of x cubed minus 15x plus 4 with respect to x between 0 and negative 4. Now this time you'll notice one of the limits is negative, and that's fine. Just to make sure that here you've got the upper limit and here you've got the lower limit. So the bigger number is going to go there and the smaller number is going to go there. Okay, so our steps are the same. So let's just try that out. 0 and negative 4. And we're going to integrate x cubed minus 15x plus 4 with respect to x. So when we integrate this, let's see what we get. So we put our square brackets down and let's integrate this. So let's increase the power of x by 1. So that'll be x to the power of 4, so x to the power of 4. And then we're going to divide by the new power. The coefficient was 1. If we divide them by 4, then be a quarter. So you've got a quarter x to the power of 4. And then we've got minus 15x, so we need to increase the power by 1, so it's going to be x squared, because it was 1, you're increasing it by 1. And we're going to take the minus 15, and then you're going to divide it by 2, so that'll just be minus 15 halves. So we've got a quarter x to the power of 4, subtract 15 over 2 x to the power of 2, or 15 or minus 15 over 2 x squared. We're then going to integrate our 4, so it'll be plus 4x. And that's it. And then put our square brackets. Now, one thing I want to mention is make sure that if you have got indefinite integration, that you are including those plus c's. That's very, very important, that if you don't have these limits, that whenever you integrate, that you do have that plus c on the end. But it's just here, because it's indefinite integration, we don't need to include that plus c there. And then we're going to put 0 and negative 4. Okay, so we're now going to evaluate this. So we're going to substitute in these values. We're going to substitute in 0. We're going to substitute in negative 4, and we'll take away what we get. So I'm just going to give myself a bit more room here because this is quite big. So we've got equals, and then open up our curly brackets, or curved brackets. Okay, now we're going to substitute in 0 to begin with. Well, now one thing I've noticed here is that we've got a quarter times 0 to the power of 4, where 0 to the power of 4 is 0, times a quarter is 0, minus 15 over 2 times 0 squared. Well, 0 squared is 0, times this is 0, so minus 0, and then plus 4 times 0, which is plus 0. So that's all equal to 0 there. Okay, so that's quite nice. And then we've got subtract, and then whatever we get whenever we substitute in negative 4 into this. So now I'm going to be a bit more careful here because it's going to be a wee bit trickier. So we've got a quarter times negative 4 to the power of 4, subtract 15 over 2, negative 4 squared, plus 4 times negative 4. Close brackets. Now remember, it's a calculator paper, so you can type this into your calculator and see what you get. And actually, I'm going to do that too. And whenever I type this into my calculator, I got that's equal to negative 72. So that's fantastic. We've got 0 minus negative 72. And when we do 0 minus minus 72, that's going to be 0 plus 72, which is 72. Or you could just type that into your calculator. And that's it. Okay, let's have a look at our next question. Okay, so this is our last question. We've been asked to integrate between 3 and 1, 6x squared minus 1 over x squared plus 2 with respect to x. So again, this is definite integration because we've got our limits. So we're going to integrate this, and then we're going to then evaluate it between 3 and 1. So let's do that. So let's write it out. We've got the integral between 3 and 1 of 6x squared minus 1 over x squared plus 2 with respect to x. Now, before we integrate this, we need to rearrange this. Now, if we think back to our previous videos on integration, whenever we've got x's on the denominator, we bring it up and we give it a negative power. So we've got, and we're going to keep the same notation here because we're not actually integrating yet, we're just rearranging it, 3 and 1 of 6x squared. Now, when we bring this up, we're going to get minus x to the power of negative 2. So minus x to the power of negative 2. So make sure you're confident with being able to bring up those x's on the denominator. And if you go back to that other couple maths video on integration, whenever you've got x's on the denominator, that'll be useful. And then we've still got plus 2 with respect to x. So it's very important here that you're not trying to integrate yet, you're just rearranging. Okay, now we're going to integrate this. So let's integrate it. So we'll put in our square brackets and let's integrate it. So let's increase all the powers by 1 and divide by the new powers. So if we increase the power of x by 1, we're going to get x cubed, and then 6 divided by 3 is equal to 2. So if you differentiate 6x squared, we get 2x cubed. Now if we integrate this, we're going to increase the power of x by 1, so it'll be x to the power of negative 1, and then we're going to divide by the new power. So we had a coefficient here of negative 1 already, minus x to the power of negative 2 would be minus 1x to the power of negative 2. So we're going to divide this minus 1 by the new power minus 1, and minus 1 divided by minus 1 will be 1. So we're going to write plus there, so plus 1x to negative 1. And then if you integrate 2, you get 2x, so 2x. And now remember, we don't write the plus c because it's definite integration. And then we're going to close our square brackets and we're going to put 3 and 1. Okay, now at this point, you could just type this into your calculator and see what you get. So you could just do, and I'm actually going to show you what you could do here in two different approaches. So one approach is you could just type this into your calculator and you could type in, you could do 2 times 3 cubed, just substituting 3 to begin with, plus 3 to the power of negative 1 plus 2 times 3, close brackets, and then we're going to substitute in 1, so we're going to then substitute in 1 as well to get 2 times 1 cubed plus 1 to the power of negative 1 plus 2 times 1. And if we work those out on our calculator and just type it all in, we'll see what we get. So if we type these into our calculator, So whenever I type this into my calculator, I get that's equal to 181 over 3, so 181 thirds. You could write it as a decimal number if you wanted to, as 60.3 recurring. And then if we type this bit in, so subtract, and if you type this bit into your calculator, we get that's equal to 5. And then if we do 181 thirds, subtract 5, let's see what we get. We get that's equal to 166 thirds, or as a decimal number, 55 and a third, or 55.333, and so on. And that's it. So that's what we'd get. So if we were asked to integrate 6x squared minus 1 over x squared plus x with respect to x between 3 and 1, the answer would be 166 over 3. I'd probably just read it like that, 166 thirds, or 55.3 recurring. Now I just want to mention here, I did say that at this point here, whenever we just type this into our calculator, what we could have done, and I'm just going to go back here and I'm going to change color of ink to blue just so you can see this is my second approach. If I didn't have a calculator, or if I was just working this out on a non-calculator question, now obviously with GCSE Further Maths it's a calculator paper, but I just want to show you that if you had this, what you could do is you could actually then just do, you could actually rearrange this and put the x back on the denominator to get 2x cubed plus, and then this would be, remember, to the power of negative 1 means you put 1 over the positive power, so it's going to be 1 over x to the power of 1, or just 1 over x plus 2x, and then we've still got our 3 and our 1, and then we can just work this out. So if you just put the x back on the denominator, it can just make it a bit easier whenever you're working it out. So if we done that, we would have 2 times 3 cubed plus 1 over 3 plus 2 times 3, then subtract, and we've got 2 times 1 cubed plus, and then we've got 1 over 1, just substitute in the 1 here, plus 2 times 1. And then we can work this out. So we'd get 3 cubed is 27 times 2 is 54. So we've got 54 plus a third plus 6. So that's going to be our 60 and 1/3 there. And then subtract, if we work this out, 1 cubed is equal to 1 times 2 is 2 plus 1 divided by 1 is 1, and 2 times 1 is 2. So we've then got here 60 and 1/3. So 60 and 1/3 there. Subtract 5, and that's equal to 55 and a third, and that's what we got. So just to mention that sometimes you can just type it into your calculator and get the answer, but also you could rearrange it and to put it into quite a nice way, just put the x back on the denominator, and that's it. So that's it. So in this video, we've looked at definite integration. So we've looked at indefinite integration earlier, so whenever we had the plus c on the end. And whenever we're looking at definite integration, or finding the definite integral, we will have our limits, and we will then integrate it. We tend not to include the plus c because we know that whenever we do subtraction, they'll cancel it anyway, and also the mark schemes don't include them. So we'll integrate it, put in our values, and take them away. And make sure that whenever you're doing it, you put in the upper limit first, and then the lower limit, and then subtract them. And then you'll be able to find what the definite integral is. And that's it. I also want to mention that on a lot of calculators, you're able to check your answers. Now, you obviously need to be able to find the definite integral. You need to be able to integrate. You need to be able to substitute in the values and work it out. And that's very important. I've actually seen questions in the past whenever we've actually had k's in here. So you need to be able to do it well. But also I think it's quite important for me to show you how to work it out on your calculator, so you can know how to type this into your calculator and get the answer, and type that in and see that the answer is going to be 24. So I'll show you how to do this now on your calculator, just because particularly whenever you're in the exam, you might want to be able to just check and see, did I get what the calculator got? So am I right there whenever I'm doing this question? And that's it. So I hope you found this useful, and if you have found it useful, please like and please subscribe to my YouTube channel. Thank you. Cheers. Bye.